Okay,
So
please.
I was just telling you that these are the mathematical formalisms, right? Typically, what will happen is both black holes and visible singularities will occur. Let me not go into the mathematical detail. Uh, you see, as opposed to the earlier paradigm, where you see here you had uh, average star going to a white dwarf and a large mass star going to a black hole kind of a thing. Now you have a new paradigm where what is happening is the heavyweight star will go to either a black hole or an exploding a fireball. Okay. So this is a change in paradigm. So you see, I was showing you this paradigm, and then here what happened was, as I said, the whole question is very, very interesting and exciting in the field of modern astrophysics and gravitation physics. So it was a big deal when Stephen Hawking accepted that yes, the visible or the naked singularities can develop, and then that became the New York Times first page article, actually, when he accepted that visible singularity can occur. I was invited before a few years to write a review article by the well-known 150 years old US magazine Scientific American, and uh, the bonus was it became their international cover story, translated in more than 20 international languages. And here is the German cartoon which the editor gave. For those of you who can read German, you see the editor is asking Cosmisen Sensor, and the scientists are discussing whether the event horizon should really form or not. A book was written by an American lawyer, La Pava, A Naked Singularity. And this is actually on American judicial system, and this is also being made into a movie. The movie must be out, I think, anytime. An actor, Angela Shelton, said, I don't want to become a black hole. I want to be like a rebel star, escaping away from a black hole. All right, away from this social waves that this whole issue created. Basically, I was coming to the last part of my talk, namely, you see, the astrophysicists ask that, all right, I mean, be there, visible singularities or black holes, whatever, how are we going to see these objects out there in the skies? So, give us observational signatures. And what are the observational implications? Can we really distinguish out there in the skies these black holes from the visible singularities? So there I was, this slide is telling you that there are many approaches like accretion disk properties around the black hole and singularities, very high energy particle collisions, gravitational lensing around these objects, the shadows around black holes, and the singularities. So I'll touch upon two things. You see, the accretion disk and the shadows. There are many other exciting things, but in the interest of time, I'll not touch them. Be it a singularity or a black hole, there is an accreting matter disk swirling around the object, and that is called an accretion disk. This is another picture of the same thing. Infalling material, and there is a jet. Now we calculated uh, the emissions, thermal emissions from accretion disks in the case of a black hole and in the case of a naked singularity. In collaboration with Daniel Malafarina and Ramesh Narayan at Harvard, we have several other papers in this series. A most recent one published just a few days ago. The most salient feature was that in the case of a black hole, as you can see, the dotted line, the emission stops beyond a certain frequency. There is no emission, thermal emission from the disk at higher frequencies. However, in the case of a naked singularity, you have emissions in much higher frequencies, as shown by the horizontal curves in the upper portion of the figure. I will not touch upon these other things, but the important point that I am making is that when the singularities are visible, are they objects like quantum stars, where actually quantum effects as well as the gravitational effects are combining together in order to give you an altogether new signature of quantum gravity. This is very, very important because the string theories today are incomplete. The loop quantum gravity has their own problems. So what I am trying to tell you, or what this particular development is telling physicists, is that, so I was telling you that the string theories are incomplete. The loop quantum gravity has its own limitations. So what I am telling is this particular physics development is telling us very important things. It can give you important quantum gravity signatures, really. And as Bob Wald pointed out, if the censorship fails, then in a literal sense, we would come face to face with the laws of quantum gravity. Whenever gravitational collapse to a naked singularity occurs in distant regions of our universe. So that's an exciting possibility. If you wanted to create a quantum gravity lab, just as we created the Large Hadron Collider, and that will be impossible. We won't have money to create that kind of a lab. However, the nature would have or could have given us a quantum gravity lab if the singularity were visible. And now let me just come to the very final part of my talk. We want to observe the galactic center, and that is the other part of the Nobel Prize this year. The compact objects at the center of gravity, at the center of the galaxies like Andromeda, our own galaxy, and so on. This is M87 kind of an object, galactic center. So they connected different telescopes, radio telescopes all over the earth, and then this is an artist depiction. They expected to see this kind of a shadow at the galactic center, another picture of the shadow. So here again, the singularities as well as black holes create their own shadows. And there are a lot of activities. Our own group here, Dipanjan Day, and our students Parth Bamania and Ashok Joshi and others have been doing a lot of work on the shadows recently. What the singularity will create, what the black hole will create, what are the comparisons, so on and so forth. Many of these details are given in my Oxford semi-popular title, The Story of Collapsing Stars. Here are the two black holes collapsing and merging. These are two very compact objects, be they black holes, be they singularities, whatever. And LIGO Observatory in Livingston and other places caught some signals of the merger of these two very compact objects. By the way, I wanted to mention that India has a good lineage. In the picture here, the person with the cap is Professor P.C. Vaidya, who was very much in Ahmedabad all his life, and his work is internationally well known as Vaidya metric. We have used it a lot. The other person is Professor A.R. Rao, a mathematician who lived 101 years, and when he was 100 years, I heard his seminar at the Central Salt and Marine Chemicals Research, a CSIR laboratory in Bhavnagar. Here is Kip Thorne. We met at the Goa conference discussing gravitational collapse. I asked him about the importance of the gravitational collapse studies, and he was extremely supportive, telling me that it's a very important subject. And then he also wrote for the back cover of my Cambridge monograph, Gravitational Collapse and Space-Time Singularities. So, in his lecture at Bangalore, couple of years ago, he said that what will be the gravitational waves forms. This is the picture. Kip Thorne is shown in the side box up there. So he said that from a black hole, the waveforms, gravitational waveforms will be of certain nature. But then Kip Thorne asked that what if the central body is not a black hole? For example, a naked singularity. Now, Kip Thorne asking such a question has a lot of importance as compared to Pankaj Joshi giving a seminar in India because he's a well-known figure. And, when he is asking about naked singularity, everybody's attention is drawn. And then he said that in that case, the waveforms will be very, very different. Here you can see Kip Thorne much more vividly. So he was telling us that you can distinguish the black holes and the naked singularities, and a lot of new physics will be discovered by the gravitational waves in the future decades. So, with that, I think I end my talk. I have told you the fate of massive stars. I have told you the theoretical developments. I have told you several observational developments. Very, very exciting. There are many papers that we have been writing, working. Both in national and international collaborations. And I was just telling Namit and Professor Raju that in local regions, wherever there are good institutions, we all should start collaborating, discussing, and collaboration is the way forward. So, with that, I think I complete my talk. Once again, I thank you all very warmly. Thank you very much.